We are taking chapter number 33 in software engineering, estimation for software projects. Software project estimation. We are not talking about computation or any mathematical formula that is already been established. We are talking about estimation. So in order to achieve reliable cost and effort estimate, there are certain options for these software projects. First thing we can do is we can wait until the project is finished or complete, and then we can estimate. The second thing is similar projects which have already completed successfully, we can base our estimates on those projects. This project, last project, this much cost, this project, this much cost, like that. And we can use simple decomposition techniques for estimating the project cost and effort. Decomposition is all about thinking the project as a big part and dividing the sub part and then finding out the cost and effort for all of them and combining them. Or we can use the empirical models for software cost and effort estimation, that is already established certain say formula or expression that has come from previous past you can say experience or results. The first is not practical. Why? Until the project is complete, after project is complete, then you decide to estimate. There is no point. Second option, because most of the time the past experience will not give you that kind of indication or good result that you can apply and tell for the present project. Most of the time it happens. I'm not saying it always, but we cannot rely always upon the similar project to give us the cost and estimate. So we will use the simple decomposition technique kind of way or the empirical models. So decomposition is all about dividing and conquering. That is, we assume the project as to be say a idea or a form of problem solving. So it's a big problem and we are solving it. So too complex, we cannot consider it. So we have to divide it into different pieces. That is, we will divide or decompose a project into major functions, sub-functions, all the related software engineering activities, and then we will try to estimate, and then finally we'll do it in a stepwise manner. The empirical estimation, the fourth point, is actually helping, complementing the decomposition techniques. A model is based on experience, historical data. So what all model we can find out is a simple function. That is, one thing is function of another thing. That is, we are saying the cost or the effort or the time. This is the function of what? This is the function. For example, this D. D is a variable. This is dependent on V, the function of V. So the cost, the effort, the project duration, all these is dependent on which factor. Just assume y equals fx. So y here is all these three, and this x is nothing but the LOC or FP. That is, we can select the independent parameter. That is, you can give process, you can give the use case or the line of codes or the function point. So we'll talk about all these, mainly the LOCs and FPs. So we have decomposition techniques. First we do the sizing, and then we do estimation. We can use use cases, and finally the problem based estimation, as you just found out, D equal FVI is based on LOC or FP and other parameters also. So there are cost estimation models like the empirical estimation technique, heuristic technique, and the analytical estimation techniques. These are the basic cost estimation models. I will see all of them, whichever is possible in this discussion. So project estimation is a problem solving, and then we assume it to be too complex. We decompose the problem Because why I'm telling you again and again? Because until you divide it properly in terms of a line of code, in terms of function point, the project planner has to understand that when the scope is decided, the next part is sizing, and sizing comes from line of code and function points only. So the decomposition is the basic parameter here. Software sizing. Now, first thing is, in order to give estimate for any project, I'm not talking only about a software project. Any project, what is the size, what will be the size, and if you want to accurately measure it or estimate it. So software project estimate depends on the accuracy of all these, depends on what you have done. That is the degree to which you have properly estimated the size of the product to be built. If you know in advance that this much broad or this much wide software I am going to make, these are the line of code, or you can divide it into functionality. So if you know that line of codes, this will be there, this will be the function, then you will be saying that, oh, I can estimate. The second thing is, once you have found out the line of code and function points and the use cases or the processes, then you may be able to translate all these into actual estimation parameters or estimated parameters. That is, once you get the size, you can tell what will be the effort required, human effort required, person month required, the calendar time, the time required to complete, and of course the dollars, the money. Then if the project planning is done so that it knows and it attributes the responsibilities and abilities of software team. That is, if you talk about the giants like Infosys and the Wipros and the Accentures, they have good team, they hire good people, and they follow a proper software engineering work environment. That is why the abilities are used. And finally, whether the requirements and the environment is stable, because until you understand the requirement, there is no point in going ahead. And wherever you work or wherever the project is being made, the software engineering environment and all the other environment like the infrastructure, etc., has to be stable. So software sizing, as I said, can be function point, it can be line of code. In project planning, the size is a quantifiable outcome. If you know the size, if you can estimate the size, you can find out the size, or you can anticipate the size from any way, empirically, heuristically, anyway, the size is a quantifiable outcome. Okay. So the direct approach for software sizing is simple. You know how many line of codes you have written or going to write. The size of can be line of code. Just count the number of instruction. We also call it as the DSI, delivered instruction, software instruction. So this is how direct approach can be done. Or otherwise, you can use the indirect approach. That is the function points. That is function, how many functions this code or this software is going to give. Function points. So this is the software sizing, either line of code or the function points you can apply and you can use. Okay, function point we have already seen in the earlier chapters, how to find it out. Putnam and Myers, they suggested 4 different approach for the sizing problem. What were there? Fuzzy logic sizing, then FP sizing, function point sizing, standard component sizing, the change sizing. These are software sizing, and size can be estimated by various parameters aspect to be kept under consideration. First of all, what is the type of project? In which application domain you are going to work? Either it is a real-time system or an embedded system or a wireless application or for say mobile application. And what are the functionality delivered? The functionality delivered is nothing but the function points. These are the basic function points. Functionality delivered. So it may happen that in some software there will be multiple functionality. There may be some less functionality in some of the project. and then the number of components to be delivered. See, the function point and functions are operation and say methods and function. Components are the combined, you can say it is a module kind of thing. So you combine various functions to make a component. So component can be delivered. For example, I'll just give you an example. This is a e-commerce website and you are making it, and mainly people will buy and you use the payment gateway. When they will use a payment gateway, that particular component is already made. You don't have to reinvent the wheel, so that components can be delivered, can be bought. The degree to which a set of existing components must be modified for the new system. Now you already have a system or a component already there, and then you can reuse it with some certain modification. So these are the size can be estimated by considering all these factors. Now Putnam and Myers, they also suggest the result of these sizing approach that can be combined statistically. You can create a 3-point or an expected value. 3-point is, I'll give you an example of both of them. Just assume there are 3 people. 3 people. And for the same size, same value or same aspect, one person is very optimistic. He's very optimistic. He says everything will go right. The pessimistic will say nothing will go right. And then most likely, he will say he's logical. He'll say, okay, this can happen, this will not happen. He's logical. So that is what we are saying, that first one is optimistic, the middle one is most likely, and the third one is pessimistic. First one will have the lowest value, last one will have the highest value, and most likely will be having middle value. So this expression is actually a PERT expression, but I'll tell you from where it has come. Because mainly we are talking about 3-point, but we will not be using it. We will be using this expected value estimate. See, say the optimism was say S optimism, the pessimistic is say SPESS. I've changed the people, okay? So don't worry about that. And the middle one, of course, we have to worry about. So we said S sub M. We combine them, divide by 3. This is called the 3-point. This is used, but in our computation, we will use the PERT. Same thing, 3-point and expected value, but only we will give certain weight. We will multiply the middle one with 4. And the division is with divisor is 6. So the first one is optimistic, second one is most likely, third one is pessimistic. And this is the size we are going to accept. In any project, the sizing approach, estimation can be done using this. Problem-based estimation. For any software project, we have to, because any estimation, anything can be done only when you are clear about the project, what we actually want to do, what we are going to solve, what is the problem in front of us. So this LOC and FP data are used in 2 ways during the software project estimation. Line of code and the function points. First is an estimation variables to size each element of the software. That is how many line of codes, how many function points. And then the baseline matrix collected from the earlier projects or the past projects, and these are used in conjunction with the estimated or estimation variables to develop cost and effort projection for the present project. For example, past project, okay, 50 functionalities were there, this was the amount, 2 lakh was the amount. So now you can project it. Okay, this time it will be 2.5 lakhs. The functionalities will be around 52. This way you can estimate. This may change, but everything will start with scope. You just know that all these things will come from scope of the project. See, the LOC and FP, they are this kind of estimation. They have some certain things in distinction, but they have some common characteristics also. But as I said, everything will start only by the software scope. So when you have a project, then you will define the scope of the project. And those statements which are written in the scope, they will be bounded. We need to bound it. We cannot have an open-ended question. For example, I will go tomorrow to meet that guy. Now, which one is that guy? You have to bound it. So you have to tell properly which guy, name of that guy. And then we will decompose this statement into individually estimated problem functions. And for each of these functions, LOC and FP can be estimated. That is, from this scope, one statement will be taken. From that, we will take out certain functions or the line of codes. We will estimate from each of these. So this scope will finally be converted into function points and the line of codes. I'm not just saying that line of code and FP are the only way. You can also use for sizing classes, object, changes, the business processes. These are always there. We'll talk about these. Basically, we'll talk about the LOC and FP, but other also sizing factors. We are going to see how to compute them, estimate the project variables using these also. Okay. First, scope is important. And the baseline productivity matrix, for example, the line of code per person month and the function point per person month, these are applied to the appropriate estimation variable now. And then we will derive the cost and effort for the function, for the value. That is, function estimates are combined because one function, second function, third function will combine all these to find an overall estimate for the entire project. For example, 50 FPs are there. We'll do it all for these 50, then they will combine. And this LOC and FP, when we take the average, it should be computed by project domain, in the project domain. So the project should be grouped by the team size, about the application area where it works, and the complexity, project complexity. It is easy, it is complex. And then the local domain averages should then be computed. Because every project and every computation has to have some local limitation and boundaries also. Okay. For example, in India, there is so much religion that things are, guided by religion, nothing else. So LOC and FP differ in the level of detail required for decomposition and target of partitioning. You'll see in the example when we'll do. LOC, decomposition is quite essential and you have to go to a considerable levels of detail in order to find out the LOC. And this in FP, what do we do? We have already seen the FP function point analysis in detail. So we have certain parameters, actually 5 parameters: inputs, outputs, inquiries, files, and interfaces. All these, how many numbers are there, we'll take. There is already a matrix, a weighting factor matrix, weighing factor matrix, and then we will put the counts here, number of input, output, inquiries, files, and interfaces, multiply with the column, even if you take simple or average or complex, and then we multiply them, and then we find the final count. This count, then we have the 14 complexity adjustment value factors, and this we will give from 0 to 5 value, and we'll just add all these 14 parameters, and there is a formula. We'll use this formula to compute the final value of a function point. See, using the historical data, intuition, then we'll use the optimistic, most likely, and pessimistic size value for each function or count for each information domain value. And this 3-point value or 3-point or expected value I'm talking about. Then the expected value for this estimation variable, that is the size. These are computed as a weighted average of what the formula you see here. As I already explained you, middle one will be multiplied by 4, others will be like that, and we add them and divide by 6 because we are giving heaviest credit or credits to the most likely estimates. So we just assume that optimism and pessimism are minimum maximum. Mostly the middle value will have more weightage. So after the expected value for the estimation variable have been determined, this historical LOC and FP productivity data are then applied. So this is an example of LOC based estimation. We have already known about the steps. We'll apply it here. First of all, we have to write the project scope. In the scope, we'll write different narrative or statements. And with these statements, we will try to find out how many functions will be made. And consequently, the line of codes we have to write. So start with the scope, then we do the sizing, function point and LOC. And then we have various expression. We'll put the expression in this FP and LOC values in that and try to find out the effort, cost and time duration. So this is how the steps will be taken. The example we are taking is, there is a software package. This is to be developed for a CAD or computer aided design application for the mechanical components. Okay. The software has to execute on a desktop workstation, and it has to interface with various computer graphic peripherals like the mouse, like the digitizer. It will have a high resolution color display, laser printer, and even the plotter, and there are various others. So first thing first, for any estimation is the project scope. Now just ask from the user what do you want and write the scope. Now you are writing the scope. It is first draft, so it is not bounded. For example, not bounded means I will go that day to this one and do that thing. So these are kind of unbounded sentences or narrations. You have to fix it and you will make it bounding. So let me tell you again, this is the project. For that, what we have to do, we have to write a scope. Now this is the preliminary draft scope. It is unbounded now. The mechanical CAD software will accept 2 or 3D, three-dimensional geometric data from a designer. So input will be this one. The designer will interact and control the CAD system through a user interface that will exhibit characteristics of good human-machine interface design. So user interface and control facilities we are talking about. And all geometric data and other supporting information will be maintained in a CAD database. So we are talking about a database management. Design analysis modules will be developed to produce the required output, which will be displayed in various devices. And then we have the software. This will be designed to control and interact with peripheral devices that include mouse, scanner, laser, printer and plotter. So here we have to have a peripheral control function, and in between we see the design analysis module also. Now every sentence what is written here in the project scope need to provide a concrete detail and quantitative bounding. So we have to bound it with certain quantitative analysis and then see how many functions we can find out. That is, every sentence have to be bounded. It has to provide proper detail. For example, let us take the example of good characteristics of good human-machine interface design. What does it mean? We have to bound it. Or what will be the size and sophistication of this CAD database? So we have to think about database management also. We have computer graphics display facilities. We have 3D geometric analysis. We have 2D geometric analysis. These are all the functions that will come out from here. Okay. Now let us assume that this scope, all the sentences have been bounded. We have all these. We have refined them. We have finally found what are the functions we need to ponder upon, deliberate upon, and then we'll make these functions. And these functions will be the basis of the sizing. Scope have already been done. And then refinement to sizing. So after further refinement, major software functions are identified. So for this, let us see here. These are the major functions. If you read that scope again for the problem, user interface and control facilities it is clearly given in there in the scope. So UICF you can call it. So there will be some estimated line of code, and this has come from where? From various decomposition technique and historical data. For example, we have made this function, for example, database management. We are saying 3350 lines of code has to be written. These are estimated line of code. So following the decomposition technique, we found out these functions, estimation table we have developed, and there will be a range of line of code which are estimated to develop the each function. That this function will take this line, this function will take this line, and this function has come from project scope, which we have bounded, refined, and thought of with respect to the function. For example, now come to our specific, say 3D-dimensional geometric analysis, 3DGA. This is the function. Now there are three different ideas we have come. For example, three people are there and they are just saying that the optimistic is saying no, only 4600 line of code will work. The pessimistic is saying 8600 LOC line of code you have to write. The middle one, the most likely will be 6900 line of codes. So these, for one function, we have to have three multiple inputs from various historical data, various inputs, where various experience, everything. So someone is saying, okay, 8600 line you have to write. The optimistic is saying 4600 line of code. The most likely is saying 6900 line of code. Okay. So now what to do? We will use the 3-point or the expected value estimation statistical result. How to use that? We will use this 4600. We will add it and then multiply 4 with 6900, the most likely. Then add 8600 with this one and we will divide it with 6. This is the final value. So we will use 6800 value, which you see in that table also. This is the estimated line of code, and this you will do for each and every function that is listed in this table. Okay, I hope you got the idea. Scope, then sizing in these three different thoughts, and then combine. So by summing all these vertically, all this LOC column, when we add this, the total line of code which we are estimating is 33,200. So 33,200 lines of code we have to write. Okay. Now we are arrived at this. And when we review the historical data, that organizational average productivity of this type of system, of CAD system, computer aided design system, we found that the result is 620 LOC per month. So in a month, a person month, PM is person month, that in a person month, one guy in 1 month will write 620 codes. Let us say that. So let us say that the labor cost or the burden labor rate is 8,000 per month, $8,000. This is the cost. So what will be the cost per line of code? See, you have already the given values, 33,200 lines of code you have estimated. You know by past 620 LOC per month, 8,000 is the dollar. So what you have to do is just divide this amount 8,000 with this 620. So what will be the cost of one line? So 12.9 or $13 is the cost per line of code. The cost per line of code is $13. 8,000 divided by 620, which is LOC per month, got from historical data. Now you see this LOC estimate and the historical productivity data. What will be the total estimated project cost? How do you know? How do you compute this? You know, one line of code is costing $13. There are 33,200 lines. So the total cost will be 431,000, or you can say $431,000. And what about the person month? How do you compute it? So this is the cost. Okay, this is in dollars. So when you have to compute the person month, the effort is always computed in person month. This is the unit of effort. Person month is one person, how much work he does in 1 month. So these are number of line of codes 33200, and you just divide it with this 620 LOC per month. So all the computation which I have done is just by using the units. I know which unit will come where. Then only you can easily find out. So this 33200 divided by 620 is going to be 53.5. Let us take it as 54 person months. So this is how we estimate on the basis of LOC. Now function point based estimation. For that, first you have to know about the function point analysis that we have already discussed. You can just revisit previous chapters and get an idea of that. But I'll give you an idea here also. First, there are 5 information domain value or input parameters. For a computer, the problem is there is a computer aided design software we have to develop, and this software package which is to be developed for computer aided design application for mechanical components. So first we write this code. All these statements, we bound it and we refine it and try to take out the functions which we have to make. So certain functions we have taken out from the project scope. So these functions we have decided. These are the functions I am talking about. That is, you have to make a user interface, 2D geometric analysis, 3D geometric analysis, database management you have to do. You have to do the computer graphics display facilities, peripheral control functions, design analysis modules. For us, CAD software, you have to do all these functions. These are nothing but function points, because function points are what? Basically, you are trying to find out the functions. So decomposition of FP based estimation focuses on the information domain values, which are these 5 values. Okay. So external inputs, external outputs, external inquiries, internal logical files, external interface files. Now, if you see the table here, we already found out the optimistic, likely and pessimistic value. And let me just put that these three, take these 3 values of one row. So first one is 20, add it with the 4th multiplication or multiply it by 4, the middle one, most likely, plus 30 divided by 6. So you get 24. So this is the estimated count. Now you have to multiply it with the weight. The weight is already there. There is already a matrix of low, average and high. These are metrics, and you can say we are taking the middle one. So low, average, complex. You can take any one of these. I am taking say average. So now multiply this 4th column with 5th column and write it on the last column. And the finally multiplied value, you just add them. You get 320. So this is your function points. Now these function points 320, because there is a formula for function points. These are not function point right now. These are just count. But the basic function count, there is a way we have to add the value adjustment factor also. So this is just a count total. This is not function point. So this is just count total. Function point has a proper formula, because the adjustment factor have to be computed by these. There are 14 values, and we gave value each of them from 0 to 5. Any value depending upon the weight of these factors in your project. So the final formula is this one: count total into 0.65 plus 0.01 into sigma fi. Sigma fi is nothing but 1.17. Okay, and then we have this count total, which is going to be 320. Multiply here, add, you get 375. Now we got the function point. The function point already we have seen, so you can just revisit. But right now the 375 is our function points. Now the organizational average productivity for system of this type in different organization, the average value is 6.5 function point per person month. This we have got historically or from other organization, from other studies, you can say. Now the labor cost is 8,000 per month, burden labor rate. So the cost per FP, cost per function point is what? See, 8,000 is the dollars, and divided by 6.5, what do you get? 1230. So the cost per FP function point is around 1230, 1230. Now we have already known the FP estimated. So total estimated project cost will be what? This is 375 and just multiply it with your 1230. So you will get 461000. So 461,000. This will be the cost, total estimated project cost. How to get the person month? For that, you already know this is 375 and just divided with the 6.5. Already given that. So you get 58. It will be actually 57.69 and assume it to be 58. 58% month will be the value. So this is an example of FP based estimation. Process based estimation, this we are going to see in the next discussion. Till then, thank you so much. Take care of yourself.